Good morning, Cappuccino. It is Monday, April 27th. Here is our warm-up for today. Starts out fairly straightforward. I want you to write an equation that would represent these given points. So in other words, an equation that all of these points satisfy. And yeah, that's it for that one. This one, solve for x without a calculator, okay? So we talked about this before. We've gone over this. What do you do if they have different bases? Okay, so give that a try. Now let's go back and look at the warm-up, the last warm-up from last week. Started out with a little bit of calculus here. The region bounded by the curve, y equals 8 minus x squared, and the line y equals 6 is rotated around the y-axis. So the first thing we want to do is we want to sketch the graph. So if I sketch this, I know this is going to be a parabola, and it's going to be an upside-down parabola, and it's going to be, if it was just x squared, it would be just your normal parabola, and since it's negative, that turns it upside down, and then this number here shifts it up. So it's been shifted up 8. I'm going to count by 2s here, 2, 4, 6, 8. So here's where the vertex is going to be, and it's going to come down like that. Okay, and then y equals 6 would be a horizontal line. So if y equals 2, 4, 6. Here's y equals 6. So it's going to be like this. So we are taking this region here, and we're going to be rotating it around the y-axis. So if you can imagine taking this little piece and rotating it around the y-axis, it's going to create like a little bowl-shaped object, and we want to find its exact volume. Okay, so really all we do care about is this piece right here. It doesn't matter that it goes on this side too. Since this is a mirror image of this, as it rotates, it's not going to, alter its volume. So really all we care about is right here. So when we set this up, we're going to have pi times this function, and it needs to be x squared, since we're rotating around the y-axis, and dy. Okay, so we need to rewrite this in terms of y. So we need to solve it for x. But notice it says x squared right here. So really all I have to do is get the x squared by itself, and then I can substitute in the equation here. So I'll show you what I mean. So we have y equals 8 minus x squared. When I do my substitution here, all I got to do is substitute in for the x squared. I already have an x squared, so let's just get that x squared by itself. I'm going to add x squared to both sides of the equations to make it positive. So I have x squared plus y equals 8. Okay, so I just added x squared over to the other side. Now I'm going to minus the y to get x squared by itself. So 8 minus y. So x squared right here, I don't have to solve this for x and then put it in and then square it. I can just substitute in, x squared is 8 minus y. So my volume is going to be equal to pi times 8 minus y dy. No need to square this, okay, because I've just substituted in for the x squared. Now I need to figure out what are my a and my b values. Well, the a value is pretty easy because it's right here. Okay, it's this value right here. That would be 6. Oh, and actually my b value is really easy too, because it's, where does it end up here? It ends at 8. So I can actually see those right on my graph. Okay, no need to do any additional work. There they are. Starts at 6, ends at 8. Okay, so now I just need to, I could even grab my calculator at this point, because the main point is, can you actually set up the integral? This integral is pretty easy to do by hand. So if you do it by hand, great. If not, if you just want to use the calculator, that's fine. The main thing is, can you actually set up the integral? So I am going to put in here 8 minus y. Since I don't have a y, I have to put it in as an x. I'm going to graph that. And then I'm going to integrate it. And I'm integrating it from 6 to 8. And it tells me my answer is 2. Okay, so if you did this by hand, you'd get the same thing. So I would get pi times 2. And the more normal way of writing that is 2 pi. So it'd be 2 pi units cubed, because we're talking about volume. There it is. Okay, you could also integrate this by hand. It's really simple. This would become 8y minus 1/2 y squared, and then substitute in your 8 and your 6. Okay, so easy peasy, lemon squeezy. All right, moving on to the next one. We have a fair die. So in other words, just your standard 6-sided die. What is more likely to happen? Rolling 3 6s in 4 rows, or rolling 5 or a 6 in 5 out of 6 throws? Okay, so this does not sound like a normal distribution. This sounds like a binomial distribution, because you're either going to roll a 6 or you're not going to roll a 6. So if you forgot how to set these up, how to do the notation, it's in the formula packet. Okay, binomial distribution. Here's the notation. So you always want to set up your notation appropriately before you start plugging stuff into the calculator. Okay, so that your professor or your math teacher or your IB evaluator can see what you did. Okay, so the first one, 3 6s in 4 throws. So let's have a look at this. Oops, in 4 throws. All right, so the probability of rolling a 6 on a fair die is 1 out of 6. Okay, and so I'm going to say my event is a binomial distribution. N is the number of trials, so there's going to be, I'm going to do this 4 times. I'm going to throw it 4 times. And the probability of winning is 1 out of 6. The probability of getting a 6 is 1 out of 6. Okay, so if I want to know the probability of getting it 3 times, that my event will happen 3 times, okay, then I can do this. Okay, I can do it the long way, fine. That's the Pascal triangle way, or I can use my graphing calculator. So I'm going to go ahead and grab my graphing calculator. Okay, so back to my graphing calculator. I want my binomial distribution. I know it's here under distributions. The normal ones are at the top. The binomial one is down here somewhere. Okay, there it is. I want option A. It's not cumulative. I just want it to happen 3 times. So my trials, there's 4 trials. The probability is 1/6. And my x value is 3. I want it to happen 3 times. And I ask for my answer, and there it is. I get 0.0154. 0.0154. And this is 3 significant figures because this 0 doesn't count because it's a placeholder. Think about if you were to write this in scientific notation. What would be your 3 significant figures? It would be 1.54 times 10 to the negative 2. Okay, so this is what I want. All right, now we got to do it for the other one, which is rolling a 5 or a 6, rolling a 5 out of 6 and 5 out of 6 throws. So my probability here, I win if I get a 5 or if I get a 6. So I have a 2 out of 6 chance of winning. And I want to win 5 out of 6 times. Okay, so my event this time, again, it's binomial distribution. I either win or I don't. There's 6 throws, and the probability is 2 out of 6. So I want to know what's the probability that I win 5 times. Okay, so now I'm going to put this into my calculator. Same thing, distribute, go down to option A, there it is. And this time I have, what did I say? I have 6 trials. And my probability is 2 out of 6. And I want to win 5 times. And I get 0.0165. So what's more likely to happen? This one's more likely to happen. So this is my winner. This one is more likely to happen. That's a bigger number. 0.165 is bigger than 0.0154. Or whatever I just said, 0.0165. Okay, all right, so there's not going to be any notes today. Instead, you're doing an investigation. We are going to be looking at arithmetic sequences and series. Those of you who took Algebra 2 maybe, hopefully, remember this from Algebra 2. If not, no big deal. We're going to learn it again. Those of you who skipped Algebra 2 and came to IB Math straight from geometry, This might seem a little bit new, but I want to tell you it's really closely, very similar to just linear equations. Okay, so nothing terribly complex here, just some new names and notations that we need to get used to. So I wanted to point out something down here on question number 4. If a sequence is arithmetic, how are the parameters of the corresponding linear function related to the first term and difference between terms of the sequence? Okay, when it says parameters, what are they talking about? So parameters of a linear function. So a linear function is y equals mx plus b. That's my linear function, y equals mx plus b. What are the parameters? The parameters are the things that define a particular function. So my parameters would be m, which is my gradient or slope. Okay, gradient, slope. Okay, that's my m. That's a parameter. And the other parameter is the b. That's the y-intercept. These are the parameters, okay? So right here, this is what they're talking about. These are my parameters. Bam, right? So when they talk about parameters, they're talking about the gradient and the y-intercept. Those are the parameters. They define each particular linear function. Okay. So this is going to be your assignment for today, is to do this little investigation, and then tomorrow we'll continue talking about arithmetic sequences and series. But let's see what you can figure out on your own. So on your mark, get set, math!